Bonjour.
Bonjour.
Hello. Well, we will now take a step back and look at how important offshore wind energy is when it comes to the fight against climate change. Cédric PHILIBERT, you used to work at the French Environment Ministry, at France's Environment Agency ADEME, at the International Energy Agency, and you're now an independent expert at Paris-based French Institut for International Relations. So tell us, what role will offshore wind energy play?
Right. I'll start with introducing you to a few scenarios laid down by the IEA in the last few years. The steps is a scenario with the current policies in place, and it basically leads to stabilize the annual greenhouse gas emissions. The announced pledge is what has been promised by the various countries in Paris or soon thereafter, and it includes the net zero commitments by the US, the UK first, Europe, then the US, also the ones to 2060 by China, the one to 2070 by India, etc. That's the announced pledge scenario. It reduces emissions to about 20 gigaton per year. And then we have what the IEA, up to the very recent years, considered the best we could do. That's a sustainable development scenario with a sharp reduction of emissions. And then, under the pressure of people after the Paris Agreement, the IEA finally published a net zero by 2050 scenario, which reduces emissions to net zero. That doesn't mean zero emissions, but that means that all emissions would be compensated by withdrawal of greenhouse gas from the atmosphere. And now let's see the climate impact of that. Of course, there are uncertainties, but basically the step would not achieve our objectives and would allow the global warming to continue up to 2.5 Celsius degree and beyond, of course. The announced pledge is a progress, but it's far from being sufficient to significantly reduce the climate change. And the sustainable development scenario and the net zero, they're close in their results. That's interesting because, of course, the lower the better. But it shows that even if we do not achieve completely net zero by 2050, we can significantly make a difference with the sustainable development scenario. So it's not vain to act, and there is no reason to despair on that action. And I think that's an important message. Now, how we would go...
Yeah. You've got the slides.
Yeah, there. But I prefer to look at my...
Well, they can't enjoy your wonderful face then.
Okay. I'll face you all. Then you have the... how do we get there? And the reason is first with wind. You see here the growth, the rapid growth we should have in wind energy. This is a graph that shows the electricity mix. But at the same time, the electricity, which is now 20% of the final energy in the world, should go up to 50%. So it's a massive electrification of buildings, transport, industry. And the first of this energy is wind power. Next is solar power. And then you have hydropower, which is still growing in developing economies in particular, and plays a role in harnessing the viability of solar and wind. Then you have the other renewables, that's essentially bioelectricity, geothermal, etc. That's only electricity, right? And then you have nuclear. Nuclear should continue to grow, but I suspect my former IEA colleagues have put here the maximum extent they believe is possible with nuclear, and you see it goes to 10%. It's a doubling of the current production by nuclear, but it does not solve the problem. Far from it at a global level. And then we have what they call made from hydrogen. I'll not detail. And then you have the various fossils. So you have oil, gas, and coal. That's the gas. It should can still grow for about 5 years, and then it must sharply reduce, and coal should reduce from now on and go to zero very clearly. So you have a little fossil fuels with CCS, with carbon capture and storage in that mix, but basically renewables and solar and wind before all, because we cannot expand hydro that easily. And solar and wind are the two only energy we have in abundance, so we can deploy them. And here you see the shares in this scenario by 2050, and you see you have basically a third of wind power, a third of solar power, all others combined to do a third, and it's basically, if you add hydro and other renewables, you get to 90% renewables. Then you have 8% nuclear and 2% fossil with carbon capture and storage. And this is very important because that's the way we could go globally to this level of emissions, net zero emissions by 2050. It's a massive recourse to renewables and a massive electrification of end use of electricity. What you see here the same in final energy demand. So looking at all sorts of energies, that includes the fuels, that includes the electricity, that includes the heat, and you see that coal should very much decline. Oil is the biggest today. It should become very marginal. This is gas, and also it should go down. Then you have nuclear. You have biomass. Biomass is important because you have many uses of biomass, in particular solid biomass as source of heat in the world and in industry. Then you have the other form of biomass, which is liquid and gaseous. This is traditional use of biomass in developing countries for cooking, basically. And now you have hydro. Look at one very funny thing here. Hydro is much smaller than nuclear. This is because this is what was called previously primary energy. So it accounts for the heat and the electricity. But the heat of the nuclear is lost. So it's big in the statistics, but in fact it's smaller in electricity, in useful energy, than hydro. And don't be misled by these graphs that do not show the real value of the various forms of energy. And then you have solar, and you have wind, and you have the other renewables to finish. So you see that the overall bilan is very interesting. And one other thing is very interesting, that the primary energy supply do not increase over current level, despite the fact that this scenario is based on 2 billion inhabitants that will be added to the 7 billion we already are, and a doubling of the GDP, the world gross product. How is that possible? Savings, sobriety, yes, that's part of it. Material efficiency, etc. Energy efficiency, of course. But electrification is a big effect. It has a big effect on this, because with electrification, you when you electrify transport, when you electrify heat with effective heat pumps, etc., you go very much down of the use of primary energy supply. So what allows this is the fact that all renewables have come down in price very rapidly in the last 10 years, and it's massive. It's for wind, it's for solar, of course, both onshore and offshore wind, and of course also for battery, and this will help for electrifying transport. And this is true despite the cost increase we've seen in the last year. It's important. We all hear of inflation every minute on the radio, etc. We have some worries about the financing of some of the plans that have been already decided, because the increase in materials is serious. But in total, it's just a few percent. So maybe some contracts have to be renegotiated, but basically it will just slow down the decrease in cost that is expected in the next few years by a couple of years, but it will not impede the energy transition.
You've been talking about onshore wind and solar energy. What about offshore wind energy? What role would it play?
Yeah, in these graphs, you've seen wind in general, and you don't know how much is onshore and how much is offshore. Here you have a response by the IEA in the latest book, and it basically suggests offshore will be a fourth of all wind. So it's important. It's an important segment, but it's not half. It's not. This is a case at a global level, and we must understand that maybe it's different in Europe. In Europe, we may have more offshore wind than we have onshore wind, or at least the same amount, basically. And you see this on this expression of the scenario that shows the offshore and the onshore wind. If you look carefully, you will see that the blue line, thin blue line that represents onshore wind, it goes up to 2030 and that it plateaus. It's very important that we do whatever we can in onshore wind as well, and that we do not delay it, as has been suggested recently by a minister in this country. We should not delay it, not because for climate change, and we should not delay it because we need to reduce our consumption of gas and our sales, our buyings to Russian gas as soon as we can. So everything we can do, we should do it right now and not wait and slow the pace to have a slow pace to 2050. We should do everything we can do in the next 10 years if we can. But here you see that, yes, in Europe, we may have a little more offshore wind than we have onshore. And the main reason is not the difficulties of acceptability. It's basically because if you look at this technology cost graph table, you'll see that in Europe we expect that the cost of onshore will come down below the cost of onshore. Because we have excellent resources, because Europe has excellent wind resources, and massive deployment will reduce costs significantly and should bring the cost of offshore wind below, with much higher capacity factors, should bring this cost below that of onshore wind. It's really a huge potential. If you compare the offshore potential in Europe to the current electricity consumption, you see that it's it's 10 times larger. And this only in looking in the economic waters. So that's very, very interesting. It's very specific to Europe, by the way. The US, China, they have some good places, but we only have the North Sea. And it's really a very, very advantageous place where we have very good winds and high plateaus, so we can do a lot with bottom fixed offshore, which is more advantageous at the beginning at least. So yes, we're privileged with this offshore wind in Europe as no other continent is. The capacity factors are excellent. To the point that the IEA has nicknamed offshore wind base load variable. So it's not firm electricity, it's still variable. You still have issues with variability, but the capacity factors could be 60%. So you have the equivalent of full power 60% of the time. That's really incredible. That's what you get, in fact, today with gas plants, coal plants, or nuclear power plants. So it's variable base load. And so the expectations in this case is Bloomberg New Energy Finance, who looks very carefully to all markets. It shows that the first is China. The big red is China. Next is the UK. The UK has a leg of advance over France, of course. But if you look UK plus all European countries, in fact, that's the leader. That is the continent Unfortunately, the UK is not anymore in the EU, but the continent is the place in the world that will most benefit from offshore wind.
You've been talking about offshore wind. What about hydrogen? Is that going to play a bigger role in the future?
Well, I think your question is on the link between offshore wind and hydrogen, and the idea of making hydrogen directly on the sea, offshore, from the offshore wind, as has been proposed by some. Indeed, some studies show that when you are farther from the shore, so it depends, from 80 kilometers up to 300 kilometers, you can do better with making hydrogen and sending the hydrogen in a pipe to the shore rather than electric connection. Fine. Not sure this actually take into account all the costs of doing that, because we have no experience of producing hydrogen offshore. Furthermore, the hydrogen, in fact, contrary to what most people believe, will rarely be used as such, as the hydrogen, because we're not going to heat our houses with offshore wind, with hydrogen, sorry, and we are not going to put a lot of hydrogen in cars and trucks. We're going to use hydrogen, as we do today, to make chemicals, to refine oil products, but except that we are not going to have oil products anymore in some time, so this will be decreased. And another use will increase, which is now very minor, which is make steel without carbon emissions, and for that we will use massive amounts of hydrogen. But all these things we're going to manufacture with hydrogen, that is ammonia, that is methanol. Maybe we'll do synthetic fuels, and certainly we'll do reduced iron, that is hot briquetted iron. All these things travel easily, while hydrogen is very difficult to transport. So maybe we'll import hydrogen from Spain or even Morocco, but we're not going to import hydrogen from Australia, Chile, Namibia, all places that have excellent resources. So in fact, the question will be, do we want to make our ammonia with offshore wind, or do we accept to import ammonia, methanol, direct reduced iron, etc.? And it's not an easy question, because we'll have, in theory, offshore wind at 40 euros per megawatt hour, but they will have a mix of solar and wind at 20 in those countries that have exceptional resources. And therefore, all these products will be produced more at a lower cost there, even with the cost of import. So there is really a question, and several European countries, Germany and Netherlands, they have already said, we're going to import hydrogen or hydrogen-based products because it will be cheaper, and we are too many on a too tiny country, and we cannot develop enough resource, although in theory with the wind they could do. So there is a trade-off here, and it's difficult. There is one thing that is important maybe, because the other big growing consumer for hydrogen will be under the form of ammonia, which is basically another form of hydrogen, that will be maritime transport, because you cannot electrify maritime transport when it's more than a few kilometers. You will put ammonia in the current engines of the ships, container ships, tankers, bulk carriers, everything. They are very efficient, and they can be adapted to burn ammonia. This is already happening with the first of these big ships being designed to be fed with ammonia. And then, if you do produce not only hydrogen but ammonia offshore, this may open interesting avenues like this proposed by Wärtsilä, in Finland, which is to create artificial islands, platform where you do hydrogen and ammonia, and then you put this ammonia directly into ships that consume it. So not ships to transport it to the shore, but ships that use it for their own propulsion, ships that transport any type of goods. And that will be very different, because you could even think of making this in the middle of the ocean, where there is absolutely no other rationale of using this energy, except maybe for our international transportation needs. And this maybe is an area for the future. Thank you very much for your attention.
Well, thank you. Very interesting things ahead. Thank you, Cédric PHILIBERT.